for the introduction and for having me today. I welcome any questions you have, so please type them, and if I go too quickly at any point or if something is not clear, please let me know. I'm happy to explain, re-explain as needed. So today we're going to talk about Query Store, which is one of my favorite new features. Maybe it's the favorite new feature in SQL Server 2016. This is my About Me slide. The most important thing on here is my email address, erin@sqlskills.com. If you have a question related to the session, please feel free to email me, or you can always reach out to me on Twitter @Erin Stellato if you're there. This is a little bit about the SQL Skills team, of which I'm a member. The owners are Paul Randall and Kimberly Tripp. And then I'm joined on the team by Glenn Berry, Jonathan Cahias, and Tim Radney. And we provide training in person through our immersion events. This year we're US only. Next year we hope to be back in Europe, although Paul and Kimberly will be in Ireland in June of this year at the SQL Saturday Ireland, and they're doing pre-cons as well. We provide online training through Pluralsight. We also provide consulting and remote DBA services, and as Maria mentioned, we speak at conferences in the US and around the world. If you're interested in hearing from us on a regular basis, you can become an insider. The link for that is at the bottom. This is a little bit of information about our classes this year. If you're looking to come to the US, we would love to see you. And then if you have never used Pluralsight, you can email Paul directly. And I love this part because I love to give out his email address. It's paul@sqlskills.com. If you want to get a look at what's on Pluralsight from the SQL Skills team, you can get a free 30-day trial. And he's got some information here about a couple of the courses. I actually have a course on Query Store. It's a full 2 hours. Actually, it might be a little bit more than 2 hours. We've only got about an hour today. So the course on Pluralsight's a little bit more in-depth. But email Paul if you're interested in the code. Just be aware that there may be a delay in him getting back to you because he's going to be traveling for the next few days. So here's the abstract for today. I'm not going to read it, and I'm sure that if you've joined this session, it's because you want to hear about Query Store. So we'll just go ahead and get started. This is what we're going to cover today. Understanding what Query Store is where we have to start, right? That's most essential. This is a new feature in SQL Server 2016. We'll talk about how to enable it and how to find information, and then we'll talk about how to force plans within SQL Server with Query Store. So I like to start the session by getting people to think about what they do all day. And that may seem odd, and some of you may pause for a moment and think, really? Is that what she really wants to know? And I do. I really like to understand what people do because database administrator is a title, and what people actually do in their day-to-day job, whether they're an administrator or a developer or an application administrator, varies greatly. So title is kind of meaningless. I really like to know what people do. So I want you to think about what your job responsibilities are. How do you spend your day, right? Are you firefighting? Are you reacting to problems? Are you writing code? Are you fixing code? Are you tuning? Are you troubleshooting? Like, what does your day look like in general, like on average? So as you think about that, right, then I want you to start thinking about, okay, as I'm going through my day, what tools do I use? What am I using to write code? What am I using to troubleshoot? What am I using to tune my queries, to tune performance? And there's a whole bunch of answers, right, when you start thinking about it. Performance Monitor is still one of my favorite tools. It's been around in Windows forever, and it's on every SQL Server that I look at until I start working with Linux, right? But there's a lot of great information in Perform still. And we have the DMVs, which have been available since SQL Server 2005, and we now have over 200 DMVs in SQL Server 2016. We have our DBCC commands, not just for doing integrity checks, but for other tasks. We've got extended events. Those are another passion of mine. If you're running 2008 R2 and below, you're probably still using Trace. That's fine. We've got query plans, another thing I like to talk about. We have Expert for advanced troubleshooting. the cumulative update and the service pack release notes, these are great sources of information, and actually something that I use in troubleshooting to look to see if what I'm seeing as a problem is already identified in a particular version of SQL Server. And you may have some other ones that you come up with. But for all of these, when we talk about using these tools, one of the things that's important to think about is whether or not you have baseline data. And I like to ask this question because it's instructive to understand how important that is and to understand how many people actually don't have baseline data, right, which is a reference point. And I think anything that you're doing related to performance, whether you're a developer or a DBA or an accidental DBA or an admin, is really important because it's important to know what query performance or performance in general looks like when things are quote-unquote normal or when things are good or typical. So if you don't know that information, then when someone says there's a problem, how do you know what exactly is a problem? Because you know they come to you and they're like, well, the system is slow, which is absolutely useless information. What does slow really mean, right? Because slow to me might be 5 seconds, and slow to another user might be 10 seconds. But I don't know, nor do I know what normal is if I don't have that baseline data. And that baseline data requires you being proactive. So up until 2016, you had to capture that information. But in 2016, we have Query Store. And Query Store is built, if you look at the documentation or you go to a Microsoft-led session, they talk about it as a flight data recorder, right? That black box that's in an airplane. That's what they compare it to because it captures information about the execution of queries. And it captures both performance information and it captures plan information, which is really cool. Now, you could capture this now, right? You can capture this in any version of SQL Server, but you've got to do it either manually or you have to have a third-party tool. And there's a cost to both. Right? Buying a third-party tool costs you money that you actually write a check for or use a credit card for or PO or however that magically happens from your company to that third-party company. Or you have to roll your own, right? You have to create your own script, and there's a cost to that because you spend time developing that and implementing it and testing it and looking at it. Query Store is natively available in SQL Server. It's the first time that we've got a method to capture information and then go back and look at it. Now, you could argue that the system health event session does that too, but this is really related to query performance, and it's available in every single edition of SQL Server. It is not an enterprise-only feature, hallelujah. It is all editions, standard edition, it's even an express edition. Now, one thing to point out, if you're looking to use Query Store, you absolutely want to make sure that you're running Service Pack 1 of SQL Server 2016 if you're using standard or express edition. There is a bug in versions prior to that, which you don't want to run into because it's related to disk space and storage and cleanup. So if you're running 2016, make sure you're on SP1 for Query Store, and I tell you to be on SP1 anyway because there were some great changes made in that release, which is a whole nother conversation. But here's a little bit more about Query Store if you haven't read about it or heard about it at all. It's enabled at the database level. So it's not instance level, it's database level, and it's per database that you care about. So if I've got 50 databases on an instance and I really only care about the performance of a couple, then I just enable Query Store for those. And when you turn this on, it starts to capture that query information and it stores it in internal tables within that user database. Now those tables are in the primary file group. You don't have the ability to configure where they're located. They go into primary. Again, they're internal tables. And the fact that they're internal tables and within that user database means that when you do a backup and a restore, those tables come with you, which can be really valuable if we want to look at comparing performance. Now, it can't be enabled for master, TempDB, or model. You can enable it for MSDB. What's interesting is that just as model is used for settings for new databases. It's also used for settings for query store. So even though I can't enable query store for model, which we're never going to use model, right? So that's fine. The settings get pulled from there. So if you find that you're using query store for multiple databases, you can change those settings for model so they'll get pulled whenever new databases get created. And I've got a blog post on how you can do that. If you want to allow people to look at this query store data, they need to have the view database state. So it's just a view permission, just to look at the data. If you want to give someone the ability to force or unforce a plan, which is a pretty powerful permission, right? Because I'm basically, if I force a plan, it's like a plan guide. I'm basically telling SQL Server, this is what I want you to try and do. And that's a pretty important privilege, so you have to be the owner in order to do that. And you can look at this data from Query Store either in the UI with the built-in reports, or you can look at it using T-SQL. So again, it's in internal tables, and there's views on top of those tables that you can then query directly to get information. Now let's take a look at what this looks like, because it's nice to talk about it, but it's way more fun to look at Query Store. So if we expand our databases here, you'll see I've got a whole bunch of stuff going on, but we are playing with wide world importers right now. So if I look at this database and I look at the properties, one of the things you'll see is that there is now a Query Store page, and you'll see that I have it enabled here. If I look at, I don't know, my movies database, let's see what I've got going on here. That's enabled as well. Let's find one that doesn't have it enabled. Ah, there we go. So that one is off, right? And it shows as being off. And if I expand that test tracking database, nowhere underneath here do I see anything for Query Store. But if I expand my wide world importers database, you'll see that I do have a Query Store tab. So when I look at the properties of the database, this is where I configure Query Store. And within the database, I have a Query Store folder, and underneath that, I have 5 different reports which are built in. Now, I have 5 in the version of Management Studio that I am running. I am running a 17X version, which is a version that is currently not supported for production. Remember, they've decoupled Management Studio from the SQL Server install. So I've downloaded Management Studio separately. There's a 16X version which is currently supported, and it's backwards compatible. But I'm running 17 because it gives me an additional report here that's queries with force plans. If you're on 16X or below, you'll see only 4 reports here. And this is how, through the UI, I can look at the Query Store data. So let's say that a user comes to me, or somebody calls, or my manager calls, and they're like, hey, the system is slow, what's going on? I can say, well, let me check, let me see. And the first thing I might do is look to see, do I have any queries which have regressed? So I double click and I get this window, which this doesn't look very impressive right now because it doesn't look like anything has regressed. But pay attention here to what's in the top left, the top 25 regressed queries during the last hour. Well, it may be that they've just regressed recently. So I can go into configure, which is way over here on the right, and I can change this time interval from the last hour to, let's say, the last 30 minutes. And I can also change, hold on one sec, let's fire this up, right? I can also change, do I want that to be, here we go, zoom this in. Do I want to look at the regression for CPU, duration, writes, reads, memory consumption, physical rates? And do I want to look based on my average, my min, my max? So we're just going to leave this right now as duration. And now I get something a little more interesting here. I get some bar graphs, and this is good, but I really don't find this as useful as looking at it in a grid format. So this button right here in the middle gives me a grid format view instead of graphical. So if I click on that, now I can see a bunch of different queries, and if I scroll over, I can start to look at execution history and recent history and resource use, right? I've got physical reads there. I have memory consumption. And if I scroll all the way to the right, one of the cool things that I like is I have this num plans, right? Number of plans. And so if I highlight the one that has 2, because sometimes these query performance issues are related to queries that have multiple plans, where one plan executes well and the other plan doesn't. So I tend to start when there's a performance issue by looking to see, okay, what do we have in terms of number of plans? But I could also look to say, well, what's running most often? And if I click, I'm going to scroll over here to the right. I know that changed really fast, but I can click on this and sort. So if I wanted to sort by execution count history or recent, I can click on that and it sorts based on that column. If I wanted to sort based on memory consumption, I can click on that. So I have lots of ways within the UI to look at this data. And again, remember, I'm looking at the metric of duration. I could change that to look at I/O, right? Maybe I care about the reads, and maybe I care about the average reads to see how those have changed over time. But if I scroll over to the right, I have this query here that has my 2 plans. And over to the right of that grid, I see the plan information, and I can see that I have this plan, which has an ID of 6, and I have this one, which has a plan ID of 1. And as I click on the different plans, you can see I have a different plan down below. And this is a cool new feature if you're not aware of it. If I highlight the plan ID, and then I hold down the control key, the shift key, and I click on the other one, you see how they're both highlighted at this point, right over here? Once they're both highlighted, I can click on this Compare Plans button, and it's going to open up those 2 plans right next to each other in a whole nother window. So this is a great way to view plans side by side, and on the right, underneath the properties, it does a comparison for me. So in addition to looking at the differences in the shape of the plan, which are immediately visible, I can look at the different properties of the operators and the plan and see what doesn't match. So this isn't restricted only to 2016. This is backwards compatible as well because it's within Management Studio. Now I'm going to pause for one quick second because you may hear my dogs in the background, and we're going to quiet that really quick. So hold on one second, and I'm going to give you back this view while I do that. Hold on. Thanks for holding. I kind of feel like the guy who was in that BBC video from last week, but it's not my children rushing in to interrupt, it's the dogs barking that interrupt. Anyway, so we can see that within Query Store, we can look at queries that have different plans. And if I click on another query, it's just going to show me what the plans are for that query, right? And I can look at any of those right here. So rather than having to dig into plan cache to pull out this information, I have this right here in Query Store, and it's all being captured for me by SQL Server. I don't have to do anything other than enable it. So this is my UI view, and I can drill into any of these in more detail. If I come into this track selected queries, it's going to open up that specific query, which was query ID 1, and it's going to give me a different view for this. So really, really easy to use. Now, if I want to look at this Query Store information using T-SQL, I can do that. Remember, I've got these system views, which are querying the tables within the database. And one of the things that I want to point out is a reminder here that this information is stored in the user database, so I need to make sure I'm in the right database when I'm querying. So if I take this query right here and I run it, notice that I'm in the context of master, and it's not going to return anything. I need to make sure to use my database and the right database because I could use another Query Store database and start looking at the wrong queries. Now I can see output. So here we're just looking for queries that exist in Query Store. I don't have any predicate on here, but I want to show you that I get the same information I got in the UI. I see the query ID information. I see the text of the query. I've got the plan of the query, which I can click on and open up. And then I have information about compiles and executions and durations. And this is all related to compilations and optimizations. If I want to start to look at additional information like execution data, which in query store language you'll hear us say runtime stats, then I can look here, and in addition to the objects that I was querying previously, I'm also querying this query store runtime stats. And I've added a predicate in this case where I'm looking at a particular query ID. So I'm going to highlight this and execute, and now I see that for query ID 1, I've got those two plans, plan ID 1 and plan ID 6. And if I click on plan ID 1, I can see that I have an index seek and a key lookup. And over here, if I look at the other plan, I have a clustered index scan. So let's close those. And these dogs are going to drive me crazy. Hold on. It's 24 degrees Fahrenheit, which is below zero for you in centigrade, right? And they want to be outside. I do not understand it. So within the UI, I can look at query and plan and text information, and I can also get that here with Management Studio with T-SQL. And I can, just as I can slice and dice that data in the UI, I can slice and dice that data with my queries. Here I want to look at queries which have executed in the last 8 hours that have multiple plans. Maybe when someone calls me and tells me that there's a performance issue, this is where I start. So now I see that for query ID 1, I have 2 different plans. And here was when it last executed, and here's the text for that. And I can then drill into that with my other views. And if I want to see what plan is being used now, then I just hit the plan cache, DM exec query plan, and say, okay, for this particular query, which is a query against, let's roll that out so we can see that a little bit better, sales customer transactions, right? If I look at that, then I can see that stored procedure and when it executed and what the plan that's in cache right now looks like. And this is kind of a red flag, right? Because, well, we're doing a clustered index scan for this. Now, scans aren't always bad, but that's still something that I think about if I see a query like that in a plan cache, particularly if I know that it shouldn't be returning that many rows. All right, so if I have any questions right now, please feel free to drop them in the box. I've got one. Let's see what this is. It says, can I set up alerts based on the information from Query Store? For example, if a query exceeds certain threshold. Absolutely. So if that data exists, you just need to find out where it is. You need to know where it is. So in this case, let's go back to this query where we were looking at runtime stats information. So a query ID is going to stay the same as long as the query text stays the same. So assuming I don't make any changes to this query text, which hopefully I'm not doing on a regular basis, I can say, okay, for query ID of 1, if the average duration exceeds a certain value, then I want you to do something. So maybe I've got an alert set up or I've got a job set up that looks for this within the query store data, and if so, then it sends me an email. So yes, you can absolutely do something like that. If there's any other questions, please go ahead and put those into the questions window, and I will definitely come back to them. So now that you've kind of got an idea of how Query Store works or what it looks like, let's talk about how we enable it and what we capture. So I mentioned real briefly in that demo that we have something called the runtime stats, and Query Store actually is 2 sets of data, this plan store data and the runtime stats store data. And the plan store is the query text and the plan for that query. And then the runtime stat store is information about the execution of the query. So the runtime stats has the last execution time, the duration, the CPU, logical reads, physical reads, writes, right? It tells me what does it look like when this query actually ran. And so if we take what we know about execution and compilation and optimization, this is where query store fits in. And this is from a Books Online post about query store. So we start with query execution at the top, and the query comes in and it gets parsed, and the optimizer creates a plan for the query, and then it goes to see, does that plan already exist in cache? And if it is there, then fetch that plan from cache and drop down to see if we are supposed to do any kind of a recompile. If it doesn't find the plan cache, then it does compilation and optimization. After it checks for recompile, then it goes on to execute. But in here, when we're checking for recompile and when we're optimizing, the plan text and query, the query text and plan gets sent over to query store. So this information gets pushed over before the query actually executes. And then once it finishes executing, then those execution statistics are sent to query store. So again, two different sets of information, and it gets written to the store actually at different times as part of this process. Now our configuration for query store has 8 settings here that are relevant. It's really 7 and then turning it on or off. So we have our operation mode, is query store enabled or not. We have the mode for capture, which means do I want to capture all of the queries that are executing, and that's the default. Do I want it to only capture those which are do I want to filter out, actually I should say it this way, do I want to filter out queries that are insignificant? Do I want to capture no queries at all? So I can have it turned on but not capture any new queries. I can specify the max number of plans for a query. The default is 200. This is an integer, so you could set this value really, really high, but I think that 200 different plans for a query is probably pretty adequate for most environments. Then I've got some settings related to storage. What is the maximum amount of storage that I want to allocate in my user database for query store? Now, this is one of those, it depends. Right? You may be thinking, well, I want to know how much space should I allocate? Well, I can't tell you because I don't know what your workload looks like. I'd said before that our queries have different IDs, and as long as that query text stays the same, then the ID stays the same. But what if you have an ad hoc workload? Queries where you get different input parameters, right? Last name equals Jones, last name equals Smith, last name equals Anderson. Each of those is a separate query, so each of those gets stored as a separate query in query store, and each of those will have a plan. So the more ad hoc my workload, the more queries I'm going to have and the more space I'm going to need to hold those queries. Whereas if I have a workload which doesn't have a lot of ad hoc queries, which is mostly stored procedures, then I'm not going to have a huge variety. I'm just going to have a high execution count for my queries. So I'm not going to need as much space. So for your max storage size, I tend to start at around 2 gigs, and then I monitor it to see if I need to increase that. My cleanup policy is, do I want to go in and clean up queries after a particular number of days? And this makes you think about, well, how long do I want to keep that query information? Do I just want to keep query information for 10 days, 20 days, 30, 60, 90? It depends on how often you need to go back and look at query performance. 30 days is the default. That's probably a really good starting point. And again, that's going to affect how much space you need. My size-based cleanup mode means when I get to that max storage, let's say that I've turned it on and I've set it to 2 gigs. When the query store gets close to 2 gigs, do I want it to start to clean up data for me? And it can do that. If I don't let it clean up data, then when it hits that max value, it actually turns off. It switches from a read-write state to a read-only state, right? So a read-write state means I can read data in Query Store and I'm capturing data in Query Store. When it's a read-only state, then I can only look at the data in Query Store. It's not capturing anything new. And then those last two settings, the data flush interval seconds and interval length minutes, those are related to the runtime stats and how frequently the information is flushed out to disk. So I'm going to hop back here to this slide. Remember I said that there's two parts to the store, one where we send our text and our plan and one where we send our runtime stats. The text and the plan get sent right away. But the execution stats are actually held in memory. There are in-memory OLTP tables which are used by Query Store. And that data is then flushed out to the Query Store tables on a regular basis. And this is an optimization. This is done because this data is stored in user tables, which means that every time I write to those user tables, I invoke use of the transaction log, right? Because it's just like a regular table. So think about how often queries execute. And if I wrote runtime statistics every time a query executed, I'm adding a lot of workload to my database. So instead what SQL Server did is they said, okay, we're going to put this data in memory and then we're going to flush it out to disk on a regular basis. And by the way, the execution stats that get stored are not for every individual execution because that would be a lot of data. And that wouldn't be how you would aggregate or store that data, nor would it be how any third party does it. Rather, there's this interval length in minutes, which is across what time span do I want to look at those execution statistics? Do I want to aggregate my reads and my writes and my CPU across a 5-minute interval or a 10-minute interval or a 30-minute interval? So this is something that you can configure, and this will also affect that max storage size. If I have a small interval, like 5 minutes, then I'm capturing more information than if I had an interval of, let's say, an hour. Okay, so there's lots of things in play here with the Query Store settings, and some of them are related to one another. And there's defaults and there's kind of some guidance, but you need to understand what these different settings do so that you can understand what may be affected by that. So a couple questions here. Is there Query Store in the SQL Azure tiers? Yes, Query Store has been in Azure way longer than it's been in the box. So it was in the release of 2016, which came out in April of 2016, and it was in Azure for months before that. So it is there within Azure now in all the different tiers. There was a question about read-write and read-only, which I believe that I answered when I was talking about that. And then what is the significance of the max plans per query? It means how many different plans for a given query will Query Store keep. So the default is 200. So if I have one query that has 200 different plans, then those 200 are going to be kept. If I get a 201, then it's not going to retain that because it's only keeping 200. So I have found that 200 seems to be pretty adequate. That's one of those things that you'll need to monitor if you think that you have huge variations in your plans. So let's take a look now at enabling this. So we're going to use our movies database, and if it exists, which it does, we're going to get rid of it. So I'm creating a brand new database. I don't want to use anything that existed. We're creating a brand new one. And I'm going to create a table that's got some movie information in it. The structure of this table isn't really critical. And we're going to add some rows. I picked movies because I really like movies, so it gives me some fun data to work with as opposed to order information. I'm going to create a table for actors. And then we'll insert some actor information into that table. And then I've got a table for cast, which basically lists the movies and the actors. This is a very small database. So we'll add some rows there. Now I've got some store procedures. And we're going to enable query store first, and we're going to do that through the UI. So let's refresh our databases. And here's my movies database. And again, I don't see the query store tab here. If I wanted to enable it, I can come into properties, I can go down to query store, and you'll see that right now it is off. So if I want to turn it on, I want to go to read write, right? I want to capture information, so I need to be in read write. I don't want it to be in read only. So if I just flip it here, you'll see that it drops in a bunch of default values, and then I can just say OK, and it's turned on. Now if I had scripted that out, this is what I would see. Set query store on, and then set the operation mode to read write. But when it does this, the other values that it's setting are right here. So it sets the cleanup policy to 30 days. So after queries have been in there for 30 days, it's going to start to age them out. It sets the flush interval to 90 seconds, which is 15 minutes. So it's going to push data from memory out to those disks, out to the tables on disk every 15 minutes. That interval length, right, that time across which the runtime stats are aggregated is 60 minutes, which that may be for you a big window. You know, if you want to look at the information in more detail, you might want to drop this down. My max storage size by default is 100 megs. That's pretty small. Remember I said I start with 2 gigs? That's pretty small. The query capture mode defaults to all. The sized-based cleanup mode defaults to auto, which means that as it gets close to that max storage size, it's going to start to push data out. And then again, the max plans per query defaults to 200. So I have some additional information in here for reference for you for what it's just some notes about this. So 30 days to me is a good place to start for the threshold. The data flush interval seconds, I've dropped it down to 60 for this demo. This value is really low, so I'm going to type in here low value. But the thing to remember here is this is how much data are you willing to use in the case of a server crash. And that data is stored in memory. So if I do a graceful shutdown, right, I'm going to go ahead and restart the instance, or I fail over to another node, right? When that happens, that data gets flushed out to disk. But if I have a system crash, there could be data in memory that doesn't get written to the tables, and in that case, I lose that data. So this determines how often that information is written, and understand that if I have a crash in here, then I could lose data. So how much are you willing to lose? 15 minutes, that's probably okay. I can drop it down. 60 is really low. As is this interval length minutes of 1, right? I'm aggregating my query store data across 1-minute intervals. That's really low. The default is 60. Here are the values to which you can change it, and these are fixed. I can only change that interval to 1 minute, 5 minute, 10, 15, 30, 60, and 1440, which is 24 hours. I think a good starting point is probably 15, and then see, do you get good information for runtime stats, and how does your query store storage look? Max storage size, here I'm setting it to 512. Again, you might want to set this up to 2 gigs. And then my query capture mode defaults to all, which I like. Auto means filter out infrequent queries and insignificant compile and execution duration queries. You don't know what those thresholds are, and you can't set them. These are determined internally, and these can change between versions, and I know that there are times when I've had queries filtered out that I cared about. So I leave this set to all. Size-based cleanup mode, I turn this on because I want it to go in and clean up, because if it doesn't and I hit that max, it turns off. Now you can monitor to look to see how much is being used and get an alert if it gets close to that limit. And again, max plans per query 200. So if I want to look to see what I have sent currently, I can do that by querying the database query store options view. So if I run that, I can see, all right, we're in a read-only state. I've got a max storage size of 100 megs, and oh look, I'm using 0. So if I want to monitor how much I'm using, this is what I want to look at, right? My flush interval is 15 minutes. The interval length is 60, and then the other settings. So let's see if I change some of these, as long as I don't have a typo in here, which I think I do, and I don't know why. Yeah, incorrect syntax near on. Let me just turn this off. There we go. So I made some changes. Now let's check my status again. Right, those show up. Now my max storage size is set to 2 gigs. My flush interval seconds, 60, really, really low. Stale threshold query is the same. Auto cleanup mode. Now let's run a query. We're going to run a query with a literal value, right? Like it would be like an ad hoc query. Give me the movies that have a release date after January 1st, 2001. So here's my output. And if I look in the system views at this point, so I'm going to go against query store query and query store query text. We see that I have my query here and the query against the movie table here. So here's my query text ID of 3, and I also have a query ID. And if I want to look to see what I have for plans, then I look at query store plan. So if I look at all 3 of these together, right, I can see here's my query 3 and 3 here. And notice that I'm getting some system queries, right? I haven't run this query or this one. So here's query text ID 3, and if I look at the plan output, then I can see for query ID 3 I have a plan, and here's my plan over here. What's kind of cool about this is that I can see the engine version, and I can see the compat mode, and I've got some other cool information about the compilation and the optimization here. And finally, if I want to look at the runtime stats, then I hit that query store runtime stats view. So I look at these all separately and I scroll back down, right? My plan ID was 3. My runtime stats are specific to a plan, not a query, because a query can have multiple plans. So my runtime stats are tied to the plan ID. So here was query ID 3 for in plan ID 3. Now here's my plan ID, and for that plan ID, this is information about the runtime statistics. When did that query execute? How many times did it execute? What's the duration look like, right? Runtime stats or execution stats are stored here. So if I look in all of these objects together, then I start to see some fun information, right? Here is that query. Now I can see the text, I can see the plan, I can see how many times it's executed when I put one big query all together. Now remember that in the plan cache you've got a different plan for a different query, and that's based on textual matching, and that's still in effect here in Query Store. So I have this first query, which is give me the information from movie info based on a release date. And I have a second query which looks exactly the same, other than instead of movie name being proper cased, it's all lowercase. And then I have a third query, which again looks exactly the same, but rather than a carriage return, it's select star from is all on one line, and I've got some spaces down here. These are 3 different queries to SQL Server because the text is different, the casing is different, the spacing is different. So when I look in Query Store, I can see that I have 3 different query IDs, even though it's technically the exact same query, with 3 different plans. So remember, if you've got an ad hoc workload like this, where there's different literal values or where users can type their own thing, then I'm going to have lots and lots of queries within Query Store, and that may not be optimal. So individual queries are captured. Now if I use a stored procedure instead, right, so I'm going to create a stored procedure that pulls information from my tables, and I execute that stored procedure with 2 different input values, so I get information about Apollo 13 and The Blind Side, 2 movies I really like. And then I query store again. And notice this time, by the way, I'm looking for a particular object ID. Now I can look at information just for that stored procedure. And within that stored procedure, remember that I had 2 queries. And query store stores query information. So it's not everything for a stored procedure, it's the queries within my stored procedure. So I have 1 query, 2 queries. So when I look at my query stats, I have 1 query, 2 queries, right? My 2 different queries are right here. And that because I ran that stored procedure twice, each query has executed twice. And then I also have the plans for those different queries. It's important to understand how it stores information so that when you're looking for regressions or problems, you know how to find it and you know what you're looking at. If I change the context of the database, right, if I use master and I use 3-part naming to execute the stored procedure, that information still gets stored in query store. So it's going to be captured. Now the reason I have another row here is because right now at this point you can't see it, but remember how there's runtime statistics within memory and then they get flushed to disk? Well, sometimes you've got information that's in disk and information that's in memory and it hasn't been all aggregated together yet. So if you ever see 2 rows for the same query ID and plan and object, don't think that there's a problem, right? It could be just that that information hasn't aggregated, hasn't rolled up together yet. It will. If I turn query store off, so I'm just turning it off, the information still exists within the views. I can still query the views, but I've turned it off so it's not capturing any more information. And I can turn it back on and that information will still be there and I can start capturing again, right? So it's just as easy as turning it back on. Now there is a command to clear out everything for query store and that's one to be used very carefully. I'll do a cleanup here in a second. So this is a point where I can take some questions. So if you've got any, type them up. I've got one. With these new features, do you see a reason why we should purchase database monitoring tools like ones from different third-party vendors? I do think those are still relevant. With this tool, with Query Store, we're only capturing information about query execution and performance and the queries that are being run. That's just one small part of tuning and troubleshooting, right? We're specifically looking at queries right here. I'm not looking at overall server performance. I don't have anything about what CPU looks like. I don't have anything about memory use. I don't have anything about wait statistics. So you have to look at a server holistically, not just at queries by themselves when you're troubleshooting. So Query Store is just one component. I still think there's absolutely use for third-party tools. That's a great question. All right, any other questions? I'm going to give us 1 second here while I get a drink of water. Hold on. All right, anything else? No, other than the dogs going crazy in the background. Awesome. All right, so now that we've seen how to use Query Store, let's talk about forcing plans. We're at like, 10 minutes to go, and I have a habit of going a little bit over, so I apologize in advance. I'll talk through this next part, and we'll see how we go. Again, all this is out there on Pluralsight, and if you've never tried Pluralsight, you can email Paul at SQLskills.com, and he'll give you a 30-day trial, and you can watch my course, which goes into more detail. So we've talked about query performance and how Query Store stores the information and how you can use it to find queries that aren't performing well. So when you find those queries, whether you're a database administrator or a developer, what do you do? How do you fix the problems that you find? whether you use Query Store or not. Right? What do you do right now? In the ideal world right now, you change your code, right, or your schema. And for those of you that are developers or who work at a company where you create your own software, this is possible. Now, it may not always be the route that your development team loves, but this is possible. But what if you have a third-party application, which I know there's lots of those out there. I used to work for a software vendor. If you can't change the code or schema, or if there's strong resistance to changing the code or the schema, then what you may try to do is get the best plan in cache. And I know this is being done because I've seen it, but imagine that I have a query that sometimes runs well and sometimes doesn't, and I figure out that it runs best with certain input parameters. And so what I do to make sure that that's the plan that gets in cache is I clear the plan for that query from cache on a regular basis and then immediately run the query with that right input parameter to get that plan in cache. Right? It's kind of like, let me work around this by not changing the code, but by just making sure that I have the plan that I want. That's not really reliable. It's possible, but there's definitely issues that can occur. You can use a plan guide. If you haven't used these before, they're not that hard to use. I don't see them used very often, but I can tell SQL Server this is a particular plan that I want you to use for a query. And now, in 2016 with Query Store, I can force SQL Server to use a particular plan for a query. Now, one thing to understand is that with both plan guides and with Query Store, the forcing is not absolute. SQL Server doesn't want your query to fail. It really doesn't want that at all. And so you should really think of this forcing or these plan guides as, here's what I want you to do, SQL Server. But if it doesn't work out, do what you think is best. Okay? Different than using something like an index hint, which may work, but if there's changes to that index or that index isn't there, then you can possibly have code failure. So SQL Server wants your code to succeed. With Query Store, as we've seen, we can find queries that have multiple plans, and then what we can do is we can force a plan. But something to pay attention to is if I add any kind of a hint to my query or I change the query text in any way, then I have a new query. I have a different query entirely because it gets a different query ID. So I have to be careful about modifying my code if I'm forcing plans. So let's take a look. This is where I start to often get a lot of questions. So we'll see how we do here. All right. We're going to go back to our wide world importers database. I've already got that turned on. I'm going to make sure that I've got the settings that I want. And then I'm going to use this query that I use rarely, never, in a production database, because what this does is it clears out all of the Query Store data. Remember in the last demo I showed you how to turn Query Store off and then turn it back on, and when you did that all the data stayed there? This is a case where I clear out all the data in Query Store. So alter database, set Query Store clear, blows all that information away. Now I'm going to create a stored procedure for testing in our database. So we've got a stock item ID that we pass in, and then we pull information from our orders and our order lines table back out. We return that. Oh, and by the way, I've got this great syntax from SQL Server 2016. Rather than do a check to see if it exists and then drop, I can just do drop if exists. I love this code. And I've got two queries in here. So I will have in my stored procedure, so I'll have two different query IDs for this stored procedure. I'm going to turn on statistics.io and I'm going to enable my actual plan, and we're going to run this stored procedure. And I'm running this with a recompile because I know that with these input parameters I get two different plans, and so I want you to see that. So here with this one I get a clustered index scan followed by a filter against the column store index scan and then a hash match. Down here I still have a hash match, but I've got an index scan against a column store index scan with my hash match and then a sort, and these are two different plans for my two different queries. And if I scroll down, it's a little bit hard to see, I have the same two plans for that second input parameter. Okay, so right now I have the same plans for both. Excuse me, I have one plan. It's hard to see this because I can't compare them easily side by side. Here's query 1. Notice I have this filter. Here's query 1 without the filter. So query 1 is different for the two input parameters. Query 2, I've got my scans, my hash match, and my sort. I've got my scans, my hash match, and my sort. That's the same. So query 1 has two different plans. Query 2 has the same plan. Now we're going to add some data because you know your database isn't static, right? Throughout the day, you're adding data, deleting data, updating data. Your distribution changes. So sometimes your statistics may update during the day, and as you know, when your statistics update, that causes a recompilation for your queries. And now we can see that query 1 has these scans with a filter, and if I scroll down, I have a different plan. So I had two different plans before. Now I have a third plan, which has a seek and a key lookup. So now for query 1, I have 3 different plans. And if I look at query 2, I again have my scans with my hash match and my sort. But if I look down, this one has a different plan. This also has an index seek with a key lookup and a nested loop. So for query 1, I've got 3 different plans. For query 2, I've got 2 different plans. And if I look in Query Store, let's refresh that and take a look. And again, we'll look at my regressed queries. And this doesn't give me any information because it's looking at the last hour. So let's look instead at the last 5 minutes, and let's look at this in terms of a grid format. And I can use the object ID or the name to easily find these 2 different queries. And if I scroll over, you can see that I've got 3 plans and 2 plans. And I can click on those plans and I can compare them just as I did before. And if I decide that performance is better with one particular plan, then I can force it right here in the UI. You see I've got this force plan button right over here. Ta-da! So let's say that I look at this query that's got our 2 different plans. And this one, that plan isn't quite as pretty. It's got my nested loop in there. And this one has my index scan, and I can see that this one is less expensive in terms of duration. And maybe I might also look at like reads and decide, well, hey, this one is lower in terms of reads. So this is the plan I want to use. So I can force it right here, and this is ridiculously simple. And remember, you have to be a DB owner in order to force plans, and some of it is because this is so simple. I mean, my mom could do this, right? I click on this and I say force plan. Do I want to force plan 9 for query 4? Yep, and that's it. Now I have this little checkbox that says this is the plan I'm forcing. For this one, I could do the same thing. Let's say that I've got plan 5, and I decide that I want to use plan 5. This is query ID 3, and this is plan ID 5. And if I come in here, I can also do this using this stored procedure. So I said query ID 3, right? Let me make sure. I have a problem remembering numbers. Yep, query ID 3, plan ID 5. So let's change that. And then if I run this, boom, it's there. Now, the quick way to check to see what has a forced plan is to double-click here and see what queries have a forced plan. This is so easy. Again, this view is only available with that 17x version of Management Studio. So now I can see these 2 different queries, and I can see which plan is forced. Pretty powerful. Now if I rerun my stored procedures, and notice that I don't have the with recompile on. If I run that and I look at my plan, I'll see that both queries have the same plans for both input parameters. So this first query is the index scan with the seek. Here is my index scan with the seek here. My second query is this not so pretty plan with the seek and the key lookup. And over here, it's the seek and the key lookup. Now, if I use another value, do I get the same thing? And I do. Now, how do I know at this point that my forced plan is being used? Well, I can look at my show execution plan, and what I can do is I can look for this text here, this use plan equals true. That's the only way that I know for certain by looking at the plan that my forced plan is being used. And remember, I told you that SQL Server doesn't want your query to fail. So if it can't use that forced plan for some reason, it won't. It will use another plan that it gets from optimization. So if I look to see what's in cache for that stored procedure, right, I can see here, here's the text, and I've got these two different plans. One is my index scan and seek, and the other is that lovely plan. Ooh, or not. What I see in cache actually doesn't match what it's doing, which is interesting. Do I have in here when it last executed? No, I don't. That might be something to add in. Hold on, this is interesting. Let me see if I can get that. That's in QS. Last execution time. Let me see what I get here. Last execution time, 103. That's current, but what's interesting is that it doesn't look like the query plan that I'm using is showing up in the plan cache. This is an interesting behavior that I've seen before, but I'm not able to replicate, and I know Grant Fritchie has seen it too, and I'm not sure at this point what it means. But we know that when I executed that query, right, let's do it again. My count was at 3, right? Here are those two plans. And if I look at my output here, the execution count is now at 4. So this is really interesting. Okay, if I look at my individual queries and I run those manually, right, those are not, these are using different plans, so they are not adhering to the forced plan because these are going to have a different query ID. And the kicker here is that there's no way for me to force a plan for this type of query because it has literal values. So if I come back to my regressed queries and I refresh, right, and I look, let's order this by my SQL text. Here are those two queries that I just ran. They have a different query ID and they have different literal values. And so if I run them again, right, 220, 130, every entry has its own query ID. So I can't force here because I'd have to force for each different literal value, and that's not going to work. And I can't try this parameterization force because this is an option that's only for plan guides. If I try and run this, it fails. And if I try and do an optimize for unknown option, well, I could do that, but I have to change the query text in order to get that to occur, and that's probably not feasible because if I could change the query text, then I'd be tuning that way. I could use a variable, and I could plan force for that, but again, I'm changing the code. So that's something that you have to think about when you're using force plans. So there's a question here about, will forcing a plan persist between server reboots? Absolutely, because as noted here, query store data is persisted in query store. So as long as I don't do something crazy like clear out my query store data, in between restarts, that data is going to stay there. So once it's been forced, it's going to keep being used as long as the optimizer can use that. Again, if there's a problem that it can't use, that it cannot use the plan that's forced, it'll use a different plan. But that persists because it's stored in query store. So unless I clear out query store or unless I unforce, which I can do, that's my dogs in the background, I'm really sorry. They've been quiet all morning and then they decide that tonight, right now is the time to be busy. But here I go, I can highlight this and I can unforce. So if something changes, let's say that the distribution of my data changes and all of a sudden this query is no longer optimal, I can unforce this particular plan. If I refresh right here, now I only have one query forced. So let's hop back to my slides. It's after 1, so I'm going to wrap up here. Some things that you want to think about with plan forcing. And I just touched on plan forcing. I got a whole nother hour that we could talk about if we had time today. Again, SQL Server wants your query to execute, so it may not use a forced plan. And you need to be careful when you're changing procedures or object names, because everything in Query Store for a stored procedure is tied to the object ID. So if I change a stored procedure by doing an alter, my object ID stays the same. But if I do a drop and a recreate, the odds of getting a new object ID are really, really high. And what happens then is I get a new query ID. So anytime you're changing stored procedures, you definitely want to make sure you do alter, and don't change your object names for forced plans like the index name, because that forced plan, the plan has the index name in it. So if I change an index name, even though the definition may be the same, the forced plan can't use that index anymore. So I've talked about Query Store just in terms of looking at regressions, right? And we can also look at queries based on resource use or differences with max DOP, with versions, with memory grants. You can also use this for testing your upgrades. This is really cool. Imagine taking a copy of your database that has Query Store in it, backing it up, restoring it in a new environment, and then running the same queries in that new environment. Then I've got my original data, and then I've got new data in Query Store that I can compare. So I could do that for hardware changes, for software or application changes. No excuse in my mind at this point for not testing upgrades, because I have a way within SQL Server to capture query performance info. And I can also test changes to the cardinality estimator. That was a new feature introduced in SQL Server 2014. It was originally tied to the compat mode. Now it's tied to a database setting. But maybe in 2016 I still haven't started using the new CE. Query Store is a good way to help you test that. And I can proactively, in my free time, right, look at my workload and see where I can make optimizations. So here's what we talked about in our short time today. We talked about what Query Store is, how to turn it on and find information, and we touched on how to force plans. If you would like more information, there's the Pluralsight course that I have, and I've got a few blog posts related to Query Store out on my site. There's a couple Connect items of interest, and if this is something that you're looking to use, I definitely recommend upvoting these if you can. If you have questions, I'll definitely take time to answer them now, or you can always email me. Again, my email address is erin@sqlskills.com. And thank you guys for your time today, and I apologize for the rowdiness and craziness of my dogs that was suddenly seems to be going on today. So anyway, there we go.
Are there any more questions? Anyone? If no, we just, thank you for presentation. Thank you, Erin, for coming. And I want to thank Jacob Andrews for all of your questions. You made this session interactive. Thank you so much. That's it. Thank you very much. And
thanks, Maria. Thank you, everyone, for having me. And again, thanks for the questions. It definitely is always great to see those, so I appreciate it.
Yeah. So see you next month, everyone. And tomorrow you will get a link with all the materials. Bye.